In January 2024, the Orpheus autonomous underwater vehicle, jointly developed by the Woods Hole Oceanographic Institution and NASA as an exploration platform for extreme environments, completed a dive in the northern Mariana Trench at a depth exceeding 10,000 meters. Orpheus was specifically designed to operate in the deepest parts of the ocean where conventional ROVs cannot function reliably, and its low-cost, high-endurance architecture makes it one of the most promising deep ocean exploration instruments developed in recent years. During that dive, the vehicle's highly sensitive optical sensors recorded a series of non-biological light flashes in an area of the trench floor where bioluminescent organism activity was virtually non-existent, according to simultaneously recorded water temperature and chemistry profiles. The images were analyzed for weeks before the Woods Hole team decided to make them public, and when they did, the scientific community's response was one of genuine bewilderment. No one had a satisfactory explanation for what the Orpheus sensors had recorded in the darkest depths of the planet. Like, subscribe, and share. Let's begin. The Mariana Trench has been the subject of systematic scientific exploration for decades, ever since the bathyscaphe Trieste made the first manned descent to its deepest point in 1960. Since then, technological advances in autonomous and remotely operated underwater vehicles have exponentially increased the frequency and depth of scientific observations in this area. The Challenger Deep, the deepest known point in the ocean at nearly 11,000 meters, was visited by Victor Vescovo's submersible from the 5 Deeps program in 2019, reaching a depth of 10,928 meters, and by several unmanned ROVs and AUVs in the years before and since. Each expedition to the bottom of the trench has yielded new data on the biology, geology, and chemistry of this extreme environment, but has also raised questions that previous observations had not yet addressed. The concentration of hydrostatic pressure at the bottom of the trench, equivalent to about 1,000 times the atmospheric pressure at sea level, creates conditions in which physical and chemical processes behave in ways that are not yet fully described by current scientific models. The luminous flashes recorded by Orpheus were not bioluminescence. This distinction is crucial to understanding why the findings so puzzled researchers. Bioluminescence is an extraordinarily common phenomenon in the deep ocean. It is estimated that more than 90% of organisms living below 200 meters produce biologically generated light as a mechanism for communication, defense, or attracting prey. The spectral characteristics of biological bioluminescence are well known, and Orpheus's sensors are calibrated to distinguish it from other light sources. The emissions recorded during the January 2024 dive had a frequency spectrum different from that of any known bioluminescent organism, a significantly higher intensity than any marine organism could produce at that depth, and a temporal pattern of flashes that did not correspond to any biological behavior documented in the scientific literature on deep-sea organisms. Spectroscopic analysis of the light emissions was performed by the Marine Optics Laboratory at the Scripps Institution of Oceanography, University of California, San Diego, which maintains one of the world's most comprehensive databases of marine bioluminescence spectral characteristics. Scripps researchers confirmed that the Orpheus emissions did not match any spectral signature in their database. The emission spectrum was concentrated in a range of wavelengths spanning from near ultraviolet to blue-green, with intensity peaks at wavelengths unusual for both biological bioluminescence and conventional artificial light sources. This spectral feature was particularly significant because it suggested that the emissions were not the result of any conventional light-generating process, either biological or technological. The alternative hypotheses the research team considered to explain the emissions included several categories of physical and geological phenomena. The first was triboluminescence, a phenomenon in which light is generated by the mechanical fracturing of crystals or solid materials under pressure in the environment of the Mariana Trench floor, where tectonic activity produces small movements and fractures in the seafloor rock. Triboluminescence could, in principle, generate flashes of light. However, the intensity of the emissions recorded by Orpheus was several orders of magnitude greater than what would be expected from triboluminescence in that geological context. The second hypothesis was sonoluminescence, the generation of light by the collapse of cavitation bubbles in liquids subjected to high-intensity sound waves. Although sonoluminescence is a well-documented phenomenon in the laboratory, its natural occurrence on the ocean floor at those depths has never been conclusively demonstrated. Like, subscribe, and share. Hydrothermal activity in the Mariana Trench area has been documented in several previous studies. The trench stretches along one of the most active tectonic plate boundaries on the planet, where the Pacific Plate subducts beneath the Mariana Plate at a rate of approximately 90 millimeters per year. This tectonic activity produces heat that generates hydrothermal vent systems, known as black chimneys and white chimneys, which emit superheated water laden with dissolved minerals. Black chimneys can reach temperatures of up to 400 degrees Celsius and support unique ecosystems found nowhere else in the world, based on chemosynthesis rather than photosynthesis. However, the water temperature and chemistry data recorded by the Orpheus during its January 2024 dive showed no anomalies consistent with the proximity of an active hydrothermal vent in the area where the luminous emissions were recorded, ruling out hydrothermal activity as a direct explanation for the lights. The Woods Hole team presented data on Orpheus's light emissions at the American Geophysical Union's annual symposium in Washington, D.C. in December 2024. The presentation sparked a lively debate that continued throughout several sessions of the conference. A group of geophysicists proposed that the emissions could be the result of a phenomenon known as deformation luminescence, in which mechanical pressure on certain types of rock produces light emissions in the visible and ultraviolet spectrum. This phenomenon has been observed in the laboratory with granite and quartz samples, and some researchers have suggested that it could occur naturally in areas of high tectonic activity. The composition of the Mariana Trench floor, dominated by basaltic rock from the oceanic crust, is not the most conducive to this type of emission, but the presence of pockets of silica-rich minerals in some areas of the trench cannot be ruled out without direct petrological analysis of the specific area. A second group of researchers at the conference suggested a completely different explanation, that the emissions recorded by Orpheus could be the result of the activity of a community of bioluminescent organisms previously unknown to science. Deep-sea exploration in recent years has revealed a surprising number of new species, many with characteristics that defy established biological categories. The possibility that organisms capable of producing light emissions with the spectral characteristics recorded by Orpheus live at the bottom of the Mariana Trench cannot be ruled out without direct biological samples from the area. Marine biologists supporting this hypothesis pointed out that exploration of the trench floor remains so limited that the presence of unknown communities of organisms with radically new characteristics is entirely possible. The follow-up expedition to the emission site was planned for the first half of 2025, with the simultaneous deployment of the Orpheus and a second vehicle equipped with biological and geological sampling equipment to obtain direct information on the composition of the seafloor and the presence of organisms in the area. The results of that expedition were being processed at the time this information was gathered, and the Woods Hole researchers expressed hope that the additional data would finally provide a scientific explanation for the emissions. However, they also openly acknowledged that the history of deep ocean exploration is full of phenomena that took years or decades to fully explain, and that patience and scientific humility are the most important tools when exploring the most extreme environments on the planet. What the Orpheus recorded in the Mariana Trench in January 2024 is an objective physical fact, measured with calibrated instruments and validated by multiple independent laboratories, flashes of light in the darkest depths of the planet, with spectral characteristics that do not correspond to any known light source, biological or physical. Whatever the final explanation, this data has added a new layer of mystery to a place that was already the most enigmatic in the ocean. The bottom of the Mariana Trench remains the least explored and least understood territory on the Earth's surface, and each expedition that reaches its depths returns with new questions that current scientific models cannot yet answer. The importance of the Orpheus vehicle as an exploration platform extends far beyond this specific discovery. Orpheus was designed as a response to the cost and scarcity of deep-sea exploration vehicles. Conventional submersibles capable of operating at depths exceeding 6,000 meters cost tens of millions of dollars, and are so scarce that the scientific demand for operating time far surpasses availability. Built with a design philosophy based on low-cost, highly redundancied components, Orpheus has a manufacturing cost of just $100,000 per unit, allowing for the simultaneous deployment of multiple units and mitigating the risk of loss without the catastrophic impact of losing a conventional multi-million-dollar vehicle. Its connection to NASA is no coincidence. The space agency's engineers are interested in technologies developed for deep-sea exploration because they are directly applicable to the exploration of extraterrestrial oceans. such as that of Europa, Jupiter's moon, where a liquid water ocean is suspected to exist beneath an icy layer that could potentially harbor life. The same technologies that allow Orpheus to operate autonomously 10,000 meters deep on Earth could one day allow a similar vehicle to explore the ocean of Europa. The broader scientific context in which the discovery of the light emissions is situated is the growing understanding that the deep ocean harbors physical, chemical, and biological processes that are fundamentally different from those occurring in the surface oceans and that, in many cases, are still not described in scientific textbooks. Over the past 20 years, each expedition to the ocean floor has revealed new species, new ecosystems, and new processes that have expanded the boundaries of what biology and geology considered possible. The discovery of hydrothermal vent ecosystems in 1977 by the submersible Alvin demonstrated that complex life could be sustained without sunlight, revolutionizing the understanding of the limits of habitability for living things. The discovery of extremophile organisms living in deep-sea rocks at temperatures and pressures that any previous biology text would have described as lethal to life expanded those limits even further. The strange emissions from Orpheus could be the next chapter in that story of discoveries that have systematically transformed what we thought we knew about the planet we inhabit. Like, subscribe, and share. See you next time.